In 9, we've got an equation involving a radical, and the way we're going to handle this is we're going to isolate this radical. That is, to get it on one side by itself, everything else on the other side. So let's start by isolating this. We can get rid of this minus x if we add x. So our plan is going to be to add x, right? And that'll give us this. Square root x plus 4 is equal to x minus 2. Makes sense. If I add x over here, I'll get plus x and then minus 2. Or negative 2 plus x if you like. I'll just write the x first. And now, to eliminate the radical, I know it's a square root. I know if I square a square root, the radical comes off. So I'm going to indicate what I'm going to do here. I'm going to square both sides. So I'll indicate it like this. The quantity, square root of x plus 4 squared, is equal to this whole right side, x minus 2 squared. And let's do this. When you square the square root, that radical comes off. We get x plus 4 equals, now on the right side, we're squaring two terms. We have our pattern for this. We'll square the first, x squared, multiply the two together, negative 2x, but we double it, so minus 4x, and then square the last, so there's a plus 4. And this is quadratic, right? This is quadratic, so we know what to do here. Get everything on one side, 0 on the other. So let's get rid of this stuff over here on that side. So how about if we do this? We'll subtract x and then subtract 4. So that'll give us 0 on the left side, right? If you subtract x, it's gone. If you subtract 4, it's gone. We'll be left with 0. Equals, okay, x squared, and then minus 4x minus x minus 5x. And then 4 minus 4, well, that's just 0. So here's what we're left with, that quadratic. We know how to solve quadratics. We factor. I can factor an x out of there. So I'm going to get 0 equals, take that x out, we're left with x minus 5, from which we will get x equals 0 or 5. Now, these are just potential solutions, because we know when we square both sides or raise an equation, raise both sides of an equation up here, raise both sides of an equation to an even power, we can introduce what are called extraneous solutions. Those are solutions that solve the quadratic, but not the original equation. So we absolutely have to check. So we need to, for sure, check these. So let's check this solution. I'm going to do it up here near the top here. So here's how I'm going to do this. Since I'm checking, I'm going to say what I'm going to do. I'm going to check. And then I'm going to say this. If x equals 0, then, all right, let's put the 0. Now I'm going to take this 0. I'm going to take that 0. I'm going to put it back into the original equation. Don't put it anywhere down here because you may have made a mistake. So put it back into the original. So we'll write it first, and then we'll do as much as we can in our head. So it's going to look like this. It'll be the square root of 0 plus 4 minus 0 equals negative 2. This will give us square root of 4 equals negative 2. Square root of 4 is 2 equals negative 2. That's false. So this doesn't work. So we know that x cannot be 0. So let's go on to our other value, 5. So we'll say it this way. If x equals 5, then, all right, so now we're going to put this 5 back into the original equation for x and compute. So we will get square root 5 plus 4 minus 5, right? I'm putting the 5 here, 5 plus 4, and then minus 5. And that says it's equal to negative 2. Well, this is going to be the square root of 9 minus 5 equals negative 2. We'll get 3 minus 5 is negative 2. We get negative 2 equals negative 2. That works. We got a true statement. So 0 doesn't work, but 5 does. So now we'll just conclude here that out of those two solutions, only one works, and that's the 5. Now in problem number 10, I can tell right away that there's no solution to this. Here's what I'm thinking. All right, I'm just going to write that here, and then we'll work it out as if we didn't know this. But notice that this part right here, that's a square root, and it's got the radical on it, so that is a positive number, right? That when you write that radical sign, when you write this radical sign, you're indicating a positive number. So this side is a positive number, and then you're saying that this is equal to a negative number. That cannot happen, right? So right up front, I know this is false, so there's going to be no solution to this equation. But suppose we didn't know this and we just worked on as usual. So what we're going to do to start, we're going to square both sides, so we'll get the square root of the quantity. Square root of 3x plus 1 squared equals negative 2 squared. And on the left side, we're going to square this square root, so the radical comes off. We get 3x plus 1 equals, on the right side, we'll get a 4. Nice little linear equation here. Let's subtract that 1, so we'll get 3x equals 3, divide, x equals 1 as a potential solution. But now we need to check this. Right, this so far, now, what was that? So far, this is just a potential solution. And potential solutions, we need to check this. All right, so let's check that. So to check it, I'm going to write it, check, say what I'm going to do, and I'm going to say if x equals 1, then, now take that 1 and put it all the way back into the original equation. So I'll replace that x with the 1, and here's what we'll have. We'll get the square root of 3 times 1 plus 1 equals negative 2. And in here, we're going to get 3 times 1 is 3 plus 1 is 4 equals negative 2. But the square root of 4 is 2, right? Because this is the radical sign, so we get the positive, right? We know 4 has 2 square roots, 2 and negative 2, but this indicates the positive one. So we get 2 equals negative 2, false. So we have to toss that one out. So we know that x cannot equal 1, and that's the only one we had. That's the only number we had. So now we're just going to claim that this equation has no solution.